Hey, it's lesson 2, and this is a big one. So this part of this unit is the core for the next 5 lessons. So this is important. Not to say that any other days are less important than the others, but here we are. Make sure in your note packet you are here on the word slope. So you're using the right page, and let's get started. So our learning target today is the same as our essential question, and we want to say how do I find slope from a table or graph? And today we're just going to focus on the graph. Today it's going to be all about graph. Now, when we talk about this, slope is an interesting thing because it measures the degree of steepness in a line that we create from an equation. So, what is slope? It is the degree of steepness in a line. Now, if you think about that, what we're talking about, is anything that's sort of angled. Like if you're going down a ski slope or up some stairs, all of those things have a slope to them. And what we're doing is we're measuring that degree of steepness based on a line that we might create from an equation. So slope itself, though, calculating it with math, is the ratio of rise to run. Now that is how much does that line change vertically, either up or down, vertically, over how much it changes horizontally. All right, and that can be positive or negative, and we'll talk about that in just a second. The other thing about slope is that it's constant. So wherever it is on the line that you measure that slope, it's going to be the same here or way, way out there at the moon or way, way down there on the other side of the planet. That line, as it extends off at infinity, the slope will never change. Slope is so important that in math, it's been given its own variable, and that variable then is m. I don't know why, but when we have an m in an equation, that m represents slope. All right, let's talk about what are the types of slope here. You scroll this up so we can see it. With a straight edge, hopefully, you're going to put 2 lines on your graph. I'm going to use this one here. Let me put one like that and one like this. So there are 2 kinds of slope that we're going to talk about today. There's actually 4. There's 2 main ones, and there are 2 special ones. So of the 4, I'm going to write here, we have slope can be increasing, and then on your paper, draw an arrow to the one that is increasing. Or it can be decreasing. Each of these is designated by a sign. So in this case, anything increasing is a positive slope. Anything decreasing is a negative slope. I realize this is early, this is brand new, but this is going to be something you're going to be very, very familiar with in probably the next week or so. So just stick with me here. There are 2 other kinds of slope that we're not going to talk about today. We're going to leave it at just this today. As you look at these, though, and this is one thing that we have to agree on as a group, because it's already been agreed on by mathematicians. As you read these, we read left to right. So when we look at this, from left to right, that's going up. From left to right, that's decreasing, going down. how do we calculate slope from a graph? Now, when we calculate slope from a graph, this is really simple. Like, I can't make anything more simple than this. It's all going to be about the mechanics and how you do this to make sure you're doing it correctly. So when we talk about finding this from a graph, the first thing we're going to do is we're going to pick a point that is at an intersection. Okay, when I say at an intersection, what I mean is, if you look at the line that I have here, I would not pick this point because there's no intersection there. What I'm looking for is on my grid, so on the grid, I want a spot where my line hits a corner. Okay? And that's usually where we can put an ordered pair because that's really easy. We know what the ordered pair is right there. So that right there is 2, 4. So I can see exactly, I go 1, 2, I can see it's right here at the 2 on this line right here. And it's right here at the 4 on that line right there. So I want to pick a point on the intersection. So it's right there. I know what the ordered pair is, and that's fine. We don't need the ordered pair for this. Now, I want to pick a second point on an intersection. And that's going to be this one. On the graph you're provided there, so that's at 3 and 6. We've got those two. Now here's the key. I want to focus this, and I'm going to say this over and over and over and over again. The third thing we're going to do is we're going to do the rise. Do the rise first. And the rise is going to tell us if it's positive or negative. So either you're going to go up or you're going to go down. Now, if you go up, it's positive. If you go down, it's negative. Now, always left to right. Just like we read, always left to right. And what we're going to do is we're going to count how much we rise. Or fall, but we never say fall. We say rise. Until we reach the level of the next point. Okay? We're going to count how many we rise. So in this case, here's my next point. So I'm going to go up here. 1, 2. Now why did I pick that spot? Here's why I picked that spot. When you're working here, what you're creating with these 2 points, and I'm going to erase this now so you can see it plainly. What you're creating with these 2 points is a right triangle. And that right triangle is the key for counting rise and run. The increase or decrease versus the left or the right. The other way, left or right. So all I'm doing is making a right triangle here, so I made a right angle. Let me bring that out. Here. I made a right angle. I went up to the height of the next point, and then I moved to the right, in this case, to where the point was. And this right angle is the key to getting this right. And then all I'm doing is counting. So 1, 2, so I'm going to write rise, run, and then it's a positive 2. I went up 2. Then the last thing we do is we check the run. And what we're looking for is we're going to go right or left. Now, if you're doing this correctly, we should never be going this way. if you're doing the rise first, up or down, always right. Up or down, always right. And the reason for that is that we're only making a decision about positive or negative on the numerator, not the denominator. So now I look at this, I've hit my right angle, I make my turn, I go one step, that makes my run 1, and for that line right there, slope equals 2/1. Why do I keep the 1? Because what I want to know is, on that line, and this is how slope works because it goes on forever, and this is the culminating point of slope here, is that this line will go on forever going up 2/1, up 2/1, up 2/1, up 2/1. If I had enough smartboard, I could draw it out into outer space, and that line would follow that rate. Up 2, right 1, up 2, right 1, up 2, right 1. Let's look at the homework, and we'll do the first 2 here real quick. So here's number 1. I've got a point here that's pretty obvious, and a point here that's pretty obvious. And my slope equals rise over run, and I'm going to do the rise first. And I've got to go from left to right. So this is my first point here, first. And I've got to count it down till I get this right angle here. So let me erase that. Let me get a smaller pen. Bloop. So now I've got 1, 2, 3, 4, 5, 6, 7. What directions did I go? I went down. So that means -7. Then my next way, I'm going from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I went 9 to the right. So that's +9. That's the slope. So each time you do this, this line would continue. If I went down 7 and over 9 and down 7 and over 9, this line would keep going on forever at that rate. That is a constant rate of change right there. Now you might be saying to yourself, Mr. Romanovich, what if it ended up like this? Well, we'd simplify it, and we'd say it's -1/2. If that was the case, that's not this one, but we'd say that's a -1/2. Let's do one more, and then I'll set you loose on these. Here's this one. Our slope is going to equal the rise over the run. We are going to go from left to right. And then don't forget the right angle. We need a right, we're making a right triangle, really. Right angle, that's our turn. Oh, no, quotes. So I'm starting on the left, and I'm going to go 1, 2, 3, 4. One, 2, 3, 4, 5, 6. Oh, there's my example right there. Slope is not 4/6. Slope is 2/3. Up 2, right 3. Up 2, right 3. Up 2, right 3. On forever. Don't neglect this idea of the right triangle here. That's the most important thing. It's sort of like a pirate map, right? 10 steps forward, 5 steps to the right. You're going to go 1, 2, 3, 4, up to 10. You're going to turn 90 degrees to the right and walk those steps that way. All right, that's a lot. It's huge. Good luck.